Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering. Welcome to another episode of the Analytics Engineering Podcast. Over the next hour, I go deep with Juan Sequeda. Juan is a principal data scientist and head of the AI lab at data.world. He's also the co-host of a fantastic data podcast called Catalog and Cocktails. Juan's expertise and passion goes particularly deep at the intersection of two fields, semantic models and AI. In fact, he's been living at this intersection for over 15 years at this point. Kind of shocking given how incredibly relevant this is to the forefront of analytics today. We spend a lot of time diving into this intersection, including the semantic web, Juan's research in how raw text to SQL performs versus text to semantic layer, and where we both believe AI will make an impact in the world of structured data analytics. Honestly, Juan is a really fun person to talk to, and I think you're going to be able to tell that we were both having a good time here. Without further ado, let's get into it. Juan Sequeda, welcome to the Analytics Engineering Podcast.
Thank you very much. It's really excited to be here. Finally, we've been at these podcast stuff for a while now, so really cool to be here.
Yeah. There's probably a bunch of folks that listen that are also a subscriber to your podcast, Catalogs and Cocktails. But I want to maybe take a second to dig back into your history, because you're a little bit of an unusual person in the data space. You have a little bit more of an academic background than most of us. I feel like data tends to be, like in the analytics side anyway, tends to be very practitioner led, and you have a real academic pedigree in computer science and AI. Can you talk us through your background a little bit? And I'm particularly interested in your academic background and as well as like this time that you spent at Capsenta developing something called UltraRap.
So I started my undergrad actually in Colombia in South America. That's where my parents are from. I was there from the ages of 10 to 20, basically. So what happened was, like, I was an undergrad, I bumped into a seminar from a professor who was coming in who introduced something called the semantic web. This is around December 2004. And that seminar changed my life because I realized what the web was. First of all, my pet peeve always, the web and the internet are two different things. People say the internet, but they mean the web, right? When they talk about the internet in the 90s, no, it's the web. Tim Berners-Lee created the web at CERN and all that stuff, and the internet forbid surf and all that stuff. Okay. So the web, I learned about the web, and then what I realized was, wow, the web is really this gigantic information space that is completely distributed. And it's like this gigantic database that you have no control of, and you can go see whatever you want and stuff. But then search became like the main thing right after at the web with Google and stuff. And the example about search, about how it was not as great at that time, it was like if you search for Paris Hilton, you're searching for the person Paris Hilton, or you're searching for the place, the Hotel Hilton in the city Paris, and which city Paris, and so forth. And that's what made me realize, syntax and semantics and all that stuff. And just going through like just my general computer science degrees of like, you have syntax and semantics.
I think that you and I are from a similar age cohort, and I was like, the beginnings of my professional career were, in the early 2000s, and certainly like I was like very internet involved in the 90s, but became involved in a professional capacity in the early 2000s. And the semantic web is definitely a concept that it had a lot of appeal to me too. Like I was a person that like worked in Oracle databases, and the idea that you could take all this not that well structured content on the web and like do something with it. But like I was clicking through in my research for the podcast, I was clicking through some links on this topic, and they're super dated. I mean, W3C docs on the semantic web date from the early 2000s, and there hasn't been like a lot of movement on that stuff, I feel like, since then.
So what? What is it? Are you implying
did like anything happen with it?
Are you implying that because it's dated, it's not useful?
No, okay, that's fair. That's fair. But like the web was moving so quickly in this period, and the semantic web seemed like at the time this like massive next phase, and I just don't feel like it ever fully took off.
Yeah, that is true. So again, so if we go back from the academic perspective, what happened is, so the semantic web comes out as a vision of Tim Berners-Lee. When Tim says the web should, from the beginning, been this web about data, not just about documents. So I do want to, we can have a whole other podcast on semantic web, and I would love to go do that with you, because I mean, we can go off on some stuff. But just to jump forward, everything we call knowledge graphs today, that is all founded on all the work that was done in the semantic web research community. So everything that Google in 2012, right? In 2012, Google started adopting all these knowledge graphs, all these RDF and semantic practices. Was it the exact same technology that was being done? No, but it's the exact same principles behind that stuff. And that's what you want to go do in science. So you're really taking this big vision and you're trying to go do this impossible stuff. And then in practice, you're like, well, that's impossible stuff I don't care about. This stuff kind of seems very practical, and I apply that here.
I guess that's probably the biggest impact, like Google's incorporation of semantic web concepts. And what's the feature called where it like returns you the specific answer at the
knowledge panels? The first thing that Google would do, and actually credit where credit is due, this was Yahoo. They had this thing, you can look it up, called SearchMonkey. And they had this thing called rich snippets. So when you, what started to happen back in the late 2000s, early 2010s was that people started to put markup on the websites. And that's basically putting semantics on the website. So if you go to schema.org today, schema.org is a gigantic schema that people have been putting together for over a decade. And people always said, oh, that's impossible. People can't get an agreement. Well, it's been happening for over a decade, and you got all the search engines folks getting together saying, what if we would agree on some sort of semantics? So if this is a page about a book, okay, what are the things that I care about books to know? So when I go crawl the website, I can get the structured data from that stuff, right? So I think per common crawl, I think probably half of the web has semantic markup on it. Half of the web has RDF graph triples underneath. So when all the search engines go off and crawl that, they're just bringing in all that graph data, basically, and that's how they bootstrap. That's how they generate their knowledge graph underneath the hood.
So this actually has worked. It's just been a little bit more under the radar than kind of the initial web build out.
Exactly. It has been working. And actually I tell people is because you don't hear it, that's actually a good sign.
It's funny. You can take all of this data, you can load it into a massive index, and then you can search on top of it. But there's no,
that's what Google does.
Like, yeah, right. And but there's no analytics. There's no, like, wouldn't it be cool to say do a select count distinct on all books on the World Wide Web? That would be awesome. I don't think you can. There's not a system in place to do something like that, right?
I'm sure Google would probably do that, right?
Yeah.
But yeah, so if you can go off and you can start crawling the web, you can do that. But so the point is that what I get interested in is you have all these technologies that kind of this vision. And I actually tell people right now, go read the original semantic web vision article that was published in the Scientific American. It was 2001. So that's authored by Tim Berners-Lee, by Jim Hendler, and Aurel Asila. So that's the original semantic web version. And if you read that today, and I've been sharing this with a lot of folks, people are like, holy shit, that's like the stuff that we're trying to go to today. Like the first paragraph says, oh, the phone call came in and they automatically turned down the music. And it was my sister trying to go organize a medical appointment with my dad who's sick and blah, blah, blah. And all the agents are talking to each other. So that's the vision, right? And so we're all still trying to get to that vision. Now, a lot of that vision today is not just the web. It's actually more with LLMs and stuff, but that vision still holds. So what happens is that I start getting interested, saying, okay, all of this is the web and documents and text. I end up going to UT. I'm transferring on my undergrad to UT Austin. And I met a professor who became my PhD advisor. And he basically said, okay, I'm hearing this semantic web stuff, but I'm a database guy. What is the relationship between all these semantic web technologies, all this RDF graph and ontologies and stuff with relational databases? And that was a question that he posed to me, which literally changed my life. Like started doing undergraduate research. I decided to do a PhD just to go work on that. The title of my PhD dissertation is literally integrating relational databases with the semantic web. So for what I started looking into is like, how do I take relational data and being able to automatically generate a graph out of that, how to automatically extract the semantics that exist within your database schemas. Because there's semantics in there. There's meaning in here, right? When you define your data models and there's meaning in there. So how do I automatically extract that? So that was one type of the work. Another one was to get into virtualization. So I did a lot about query engines and saying, hey, if I start defining these ontologies, now we call them semantic layers, it's all the same stuff, right? So if you start defining that, you want to go create mappings, these transforms, these rules from the source to the target. And then how do I do query rewriting effectively and all the optimization? So I want to be able to write a query in terms of that target schema, ontology, semantic layer, and then use those mappings to rewrite them to your query over the source, and how to do that with optimizations, all that stuff. So I did a lot of theory and systems, all that stuff. And the deliverable, the software deliverable, was this system that we called UltraRep, which was, we commercialized that back in 2000. We started early on, like over a decade ago, 2012, 2013. We did that. And that technology was acquired by data.world. That's why data.world acquired my company.
I did not make that connection. That's very interesting. So you've really only had one job post your PhD.
I'll say I've never had a job.
Okay.
The only job I've ever interviewed for was to be a camp counselor when I was like 17. It's the only job I had to interview for. I've never interviewed for a job before.
Nice.
I just publicly said that. Okay.
I have often wondered the same type of thing that you have spent your whole academic and professional career in, which is just to say that often it feels like all of the advances to data processing technologies. Now, okay, there's the cloud and scalable cloud data warehouses and all that stuff. And that's a big, important trend that has impacted analytics significantly. But there's all these other types of more statistical techniques that really became popular in the early 2000s and have grown in sophistication over the past 2 decades. And it often feels like your plain old basic data analyst, aka me, hasn't really gotten to take advantage of a lot of that stuff. And it feels like you're kind of working in the intersection of these two fields and trying to say, like, how can we take a lot of the advances in one and apply it to the other? Is that a super high level, unsophisticated summary?
No, I think that's spot on. I call myself somebody who likes to build bridges between different communities. And those communities are between industry and academia. I try to build bridges between the semantic web and graphs and the database community. I try to build, even within the academic community, I build bridges between theory and more systems builders. So yeah, I personally enjoy zooming out and seeing a bigger picture. I'm like, I see these gaps. I see these silos. I'm like, and if only these people would talk together, like we would all advance more. But at the end of the day, we're like, everybody's reinventing the wheel in their own way. And it's just frustrating to go see. It's like, oh, you know, that thing that you just did that you're really pretty proud of? Like, you would have spent talking to somebody over here. You would have not only just not done that better, but you'd have actually done more.
Let's talk about data.world. If any kind of listener goes to data.world today, they will see a page that promotes a data catalog. And there are a lot of data catalogs in the world. And so how would you summarize data.world to somebody who has probably seen demos of many catalog products and maybe uses one in their day-to-day life? Like, what's the difference?
So we're an enterprise data catalog. We're built on a knowledge graph foundation. And kind of the three main applications that people focus on are on search and discovery, are in data governance, and on data ops. Those are the kind of the three main things that we go do. That's our platform. And I agree. There's so many data catalogs. I think at the end of the day, data cataloging, all these features are being commoditized. What I tell people is, first of all, one, we're completely cloud native, right? So other catalogs in the market, they say they're cloud. That's one. Okay. So that's one differentiator. Second, when it comes to, for example, when it comes to governance, I think there are other people who do very lightweight governance, or other people who do very hardcore governance. And I think we find a balance in the middle of the type of governance you want to go do. So we're more of an agile governance, we're automating governance, and like you can go talk to other people around it. Now, from a company perspective, also, we are obsessed about customer adoption.
There's a lot of catalogs that are shelfware.
Yeah, exactly. We are actually bonused. Like our company is bonused on customer adoption.
Love that.
Everybody. So you're bonused on revenue and we're bonused on customer adoption to do that. So that's what everybody is focused on that. And then, so we actually have I think the biggest stories when it comes to customer user adoption. I mean, we have one of the largest consulting firms in the world, right? Talking about 30,000 users. Like that's right. They have, Indeed is a customer of ours, right? And they actually had their own homegrown catalog. They built us. And I think the adoption they've had with us, they haven't been able to achieve it like in 10 years. So we have all these stories we can talk about. Adoption is really about that. So adoption is very clear. very, very, very a key thing for us, which also shows us the partnership. We're not just a vendor. We don't want to be just a vendor. We want to be a partner on that. Also, we're a public benefit corporation. So in addition to maximizing shareholder value, we have a public benefit mission, which is to be the world's most abundant and meaningful data resource. So we actually continue to host like 500,000 open data sets in the world. So we actually have over 2 million users our open data catalog. So we get to learn a lot from that too. So we have that also kind of the stories of how we can do adoption, understand learning on the adoption, and be able to do a lot of user interface, UI, UX type of testing and stuff. So, and then we can tailor to all the business users and the more technical stuff. So I can go into the details of I mean, I don't want to turn this too much of the sales pitch, but one thing I do want to add because of the knowledge graph here is a pet peeve of mine is that I don't like the word data catalog because a catalog should be much more than cataloging data. It should be cataloging data and knowledge. So the knowledge graph, what gives you is the whole flexibility to be able to catalog anything. And I think that's one of the big kind of technical differentiators where you can then drive more to business differentiators. So in addition to cataloging tables and columns and dashboards and ETLs and all that stuff, obviously DBT, right? You want to bring in your people. I want to bring in their orgs. I want to bring in their business processes. I want to bring in anything that you want to connect because at the end of the day, you don't only want your data ops about your lineage of your data. I want to understand the business, and you start building the context of your business, and that's your brain basically. And that's all the semantics, all the meaning that you're putting together. And that is key for this AI world that we're in because all these AI models,
context
stuff, they don't know the
better.
context.
Yeah,
exactly. Why data.world? But why do you actually want a catalog? Why do you want knowledge graphs in your catalog management metadata? Because you are building that enterprise brain, which is that context, which is critical for this AI world. Without it, you're not going to succeed.
Okay, I want to go to AI. And that's like a big chunk of the conversation I want to have with you. But before we go there, let's just talk about not data.world specifically, but catalogs as a category. You were talking about your pet peeves with catalogs, but mine is catalog feels like dictionary, feels like encyclopedia, feels like a place that you go to periodically to learn a fact that you didn't know. And many catalogs today, or many software vendors that make what are described as data catalogs today, I think are starting to do more than that. And so I think that the descriptor catalog feels too passive. And in fact, you start to do observability and lineage and all of these things that are more action-based. Is this a focus for you folks as well? My assumption is that you don't just want people to go to data.world every once in a while when they happen to think of a question that they'd like to ask about their metadata.
You're spot on. I think, so again, let's zoom out. If you look at the data management world, I would summarize all the tools into 3 main buckets. You move data, you store and compute data, and you use data. That's it. So moving is ETL, ELT, T, I mean, that's where you guys fit in. DBT fits in. So storage and compute, database, data warehouse, data lakes, lake houses, all the same stuff, right? Just storing and computing. Using data, reporting, dashboards, ML, AI. So you're just using the data. So what's happened is that throughout just data, enterprise data management in the last 30 plus years, we've been focused on these 3 things. What we have not focused on, and we've kind of left on the side, has been this notion of metadata. And it's just been something, that little thing on the side or whatever. And we've gotten to the point that we just have so much of this stuff that metadata is kind of like the reason why we care about it, because I can't find my data. I mean, the reason the first catalog started being built and stuff was because we went to Hadoop and data lakes. Oh, we're going to have all this bunch of data. And then we're like, people are like, oh, they're going to have all these lakes turning into swamp. I can't find my data. So I need to search my data. So that was the first use case. And that's why this era of catalogs came in. But if we go back to the history of catalogs, like library sciences have been doing all of this for decades and decades. And this goes back to like the first libraries, the Library of Alexandria, to go find things. But also,
I have written that blog post before, and it got so messy that I was just like, nobody needs to read about this.
Well, I actually gave a talk at Day-to-Day Texas about the history, what I call the past, present, future of data catalogs. And it was just fascinating to kind of like say, look, we've been doing all this stuff from the past. And what has it been in the past? It has been about organizing our knowledge, because I want to go find things. I want to go do things. I want to go do things I didn't know about. I want to discover things. So I've been trying to organize our knowledge, and that's what we've all been trying to go do for so long. Then in like the big data lake era, we just got focused so much in the data and helping to go find the data. And I think what's coming back now is that people are realizing, look, in addition to finding the data and what does this mean, it's like there's all this other knowledge around there. It's not just about the data. It's also about how does this business work? What does a customer mean? Oh, there's so many definitions of customers. Well, what are they? Let's actually figure them out. It's in people's heads. Okay, great. We now have fantastic AI technology that can help me somehow. Can you go talk and get transcriptions and go do this stuff? Like we can now start building that entire map, the entire semantics, the layer, the ontology of what this business means and start putting it together. Now, the first application that you want of that is to start creating all those connections between moving data, storing and computing data, and using data. That's that first layer. That's what we're seeing what metadata management data catalogs are doing today. But that's just scratching the surface. So I think the next thing is about like, you're going to have your enterprise brain of your organization and call that a database that manages, understands everything. That's where the catalog should be going. And then you're going to have all your data, which is the raw facts.
Like, I don't think catalog is a good descriptor for that, right?
I agree. I completely agree. I mean, call it a knowledge catalog, but damn it,
Yeah,
IBM has it with their names. Call it knowledge. I don't know. That's why there's a reason why I'm not in marketing.
I agree. It's that things start sounding fluffy and buzzwordy when you go down that route. But
Yeah.
It's, as of when we're recording this, I am doing our company kickoff next week. And one of the things that I'm doing while I'm on stage is trying to paint a picture for what the life of data practitioners will look like in 2030. And maybe the biggest theme that I see, okay, like AI is a big part of it, but like underlying all of it, I have this core assumption that there will be a metadata platform that knows all the things and can supply that context in real time to the places it needs to be supplied, whether it's, an agent or whatever, it doesn't matter. So I think that we're kind of describing the same thing here.
We're definitely on the same page. I think about it like human nature is to always inventory things. We want to be able to categorize things. We want to be able to connect things. That's just our human nature. We want to do that, right? And why do we do this? Because we want to organize stuff, right? I want to have an organized closet. I want to have organized. Now, do I achieve that is another thing, but I want to organize things. I want to be able to go find things. I want to be able to go discover things, right? I mean, that's just the human nature why I want to go do things. And I think by focusing right now, we're doing that by organizing, understanding what's in our lakes. I mean, that's kind of where this all started. I'm like, okay, great. All that now is commoditized. Like that's just features. Everybody's doing these things. Let's zoom out and like what really we need to be able to go manage. For me, it's always been the knowledge. And I call this working with Tim Gasper, my podcast co-host is, I call it a shift from a data first world to a knowledge first world. So a data first world is where we live in today. And I'm like, oh, I need more data. I'm like, really? You're telling me you can't solve that problem because you lack data. So if I give you more data, you're going to solve the problem? Yes. But that's where we live in, right? So then a knowledge first world is one where I'm actually now like people are first class citizens, connections are first class citizens, right? Relationship, like that's the type of stuff that I want to go to understand. So it's like, the example I always give is like, here's a column and the column has length, right? There's a null value in it, but there's numbers. Okay, what does that mean? Oh, that's the height of a warehouse. Oh, okay. So I start getting more context around that stuff. And why do I care? Why? So we talk about data quality. Why does that need to be correct? Or like, oh, well, first of all, if I know the height of a warehouse, I know what that null means now. Every warehouse has a height. So it's unknown. It's known. Somebody knows it. I just don't know what it is in there. And what happens if I have the wrong height of a warehouse? Man, I sold more space than I should have, right? Or I could have sold more space. So there's business value that associated to having the right quality, knowing the semantics. Like that's the world that we should go to. And we need to be able to start treating that, what I call that knowledge work. And this is really knowledge engineering work that people have been doing. Knowledge engineering was a big thing in the 80s and 90s. It was much more manual. It was harder. We have methodologies. And that's kind of one of the reasons we went into an AI winter in the late 80s, early 90s. I've been pushing and talking about we need a resurgence of that knowledge engineering work. Call it knowledge engineering 2.0 or whatever, with using all the technologies that we have today. That is and the thing is that we are already doing that knowledge work. We just don't either realize it or we're annoyed by it because we think we don't want to go do that. I mean, documentation in a way is a type of knowledge work, but that I think we need to have that paradigm shift of saying, knowledge work is something that we need to be treated as a first class citizen. And it's the reason why we're not able to accomplish fulfill all the promises that we've been trying to go do. And it's the reason why the problems that we're trying to go solve today are the exact same problems we're trying to go solve 30 years ago. For me, it's a social paradigm shift and we need to focus on knowledge work.
Yeah, I'm with you. or we've been talking around the edges of AI for a few minutes now. Let's fully go there. Maybe a place to start. You and a couple other folks, I think, at data.world wrote a paper.
Yeah, Dean Alamang and Brian Jacob.
Yeah, that paper ended up going around the thought leader space in the data community pretty widely. Can you summarize the key results there?
The main takeaway there is that if you want to do question answering over using large language models and question answering over SQL databases, you need to invest in knowledge graphs to have higher accuracy. That is the main takeaway. Invest in knowledge graphs provides higher accuracy for large language model powered question answering systems over enterprise SQL databases. The research question that we had, and we really did this as research.
Yeah, I was actually surprised at how formal it was, given you do work for a for-profit business that has not achieved Google scale yet. I was like, oh, these guys really wrote an academic paper.
Well, because Dean and myself are both academics at heart, and we actually had this hypothesis, and we have this question which is unknown, number one. And here's the other thing is that actually the folks at Snowflake were the ones who kind of challenged us to go do something like this. So we were at Snowflake Summit last June, and they're like, okay, yeah, we get that the semantics and this knowledge graph stuff is, how does it do it? How actually does it improve this? And you're like, good question. Like, I have a big hunch that it's going to improve. I just don't know how much. So the question there is twofold. Number one is everybody starts playing around with, large language models and text to SQL. Oh, this is easy. We can go do this. Great. World's going to be much better. I'm like, wait a minute. First of all, you're all testing on like very simple questions and on very simple database schemas. This is all very cute, but what does it mean for the enterprise for a second? Like, how well does that work? Number one. And second, if you put knowledge graph semantics in the middle, how much does that improve? I expect it's going to improve. It's going to improve. I just don't know how much. So the questions were always to what extent that is. Now, another thing that happens is that text to SQL is something that the research community, and there's already been companies around this stuff, have been working on for at least 3 decades or more. I mean, I think the beginning of computer sciences are. So, and then there's academic benchmarks around this stuff. And then what I see is that the academic benchmarks are really disconnected from the enterprise world. So our motivation is, let's understand to what extent the large language models actually can do this stuff, how much knowledge graphs can actually improve this, and then actually make something that is related to the enterprise. So the benchmark that we come up with is, first of all, it's not just like I want people to take away, it's not just the benchmark itself, it's the framework that people should go reuse to go test on their own stuff that they're doing. So one, you have your enterprise schema. So we use something from an open standard in insurance from OMG. The questions, what we did is that we put them in 4 quadrants, 2 spectrums. The complexity of the question, easy questions to harder questions being metrics and KPIs, and then a complexity of the schemas. Do we need a couple of tables or do I need a lot more tables?
And interestingly, it seems like generally the system had an easier time dealing with question complexity than it had with schema complexity. Schema complexity was harder. Is that fair?
Yes. And I think what happens, by the way, why is this stuff happening? Good question. Really, nobody knows because I don't know what's happening inside these large language models, right? So we could always continually speculate around this. I also want to go the setup of the benchmark and what we tested was something super, super simple on purpose because I wanted a basic baseline that anybody can reproduce, and it's regardless of any systems. So it's just one zero-shot prompt, and the prompt is literally, right, here's your schema, blah, generate the query and so forth. And just by doing that, we saw that 3 times more accuracy increase if you are doing things in terms of a knowledge graph. We have that semantics. So the whole point there is that you have to have had invested in that semantics, right? So the next question is, well, how much is that investment going to cost? Great. That's the next work that we're trying to go do is how do we reduce that investment?
Are you in process of that right now?
Yeah. And that's the knowledge engineering work that we want to go do. And that's how do we use really all these LLMs, these GPTs as co-pilots for my knowledge engineering work. I want to be able to define all these mappings. I want to come up with these semantics. Like I should have my assistant all there all the time. And so I can reduce the time to go create that metadata, which at the same time, it's like, well, how do I accelerate the management and the creation of metadata in my catalog and do that at a scalable way? That's what we're realizing then. It's like, okay, if I want to be able to have that accuracy for the enterprise for this question answering, that means I need to invest in data catalogs and metadata, but damn, that's still hard to go do. We need to make that process even easier. And that's a lot of work that we're doing now too.
What if we skip 5 years and everything goes exactly as you planned? You do a bunch more studies and everything works well and you continue to productize stuff. Where does this us?
The vision I have is that, first of all, we'll have that being able to interact not just with our data, but with our organization, our business. You can really ask any question about your business. So if you think about like the question, you get a question, right? First thing I want to go do is understand, what type of question is this? Is this a question that is related to the body of knowledge that I have or not? Are you asking me about my parents? Like, no, I don't know anything about that stuff, right? So are you asking then a subjective question? Oh, where should I go invest next year? Like, well, I can, right? You're just trying to figure out the type of question. Are you asking a fact-based question? Okay, all right, okay, fact-based question. Let's go down that route. So you're asking a fact-based question. Are you asking a fact-based question that needs data, like that's stored in a database, or do you need something that is on more the metadata side? Oh, okay, no, you think about the data because you're asking questions about the revenue. Then you go down that route, right? Then you're like, okay, you're asking. So you continue. So this is the type of stuff that the systems, the agents, right? These AI systems will be doing. And then you start asking this question, and like, oh, I can't answer that question because I don't know about this particular concept. There's nothing I know about it, but I believe it could be here. What about it? So you have like this back and forth kind of conversation with the systems around it. Or you say, hey, you're asking a question. Guess what? Somebody asked that exact same question recently and they have an approved governed answer. So here's the answer that you want. Or here's related questions that have been asked. And maybe that would be interesting. By the way, Bob and Alice are the people who are behind that. So you may also want to go talk to Bob. So that's the future when to go. And then it's, you know what you know, and you know what you don't know. And when you don't know something, then all of that itself can get back in catalog saying, here's the list of things that I don't know. And you figure out, well, that stuff can get automated. That part, we need some humans to go in and check that and so forth. So that's the vision that I see, that at some point people start out knowing very little, but then it will start knowing more and more. And then at the end of the day, all of this is, you need to make sure that it's just trust. And trust for me is accuracy, it's explainability, and then the governance part goes in there because you need to have like some seal of approval around that. And another pet peeve I have here, I got a lot of pet peeves about when it comes to explainability, especially in the kind of academic AI world. People talk about explainable AI. Nobody talks about explainable to whom. So this is another thing we work on. It's like, oh, I want to explain this answer. Well, that explanation needs to be tailored to that particular persona, right? You don't want to get an executive an explanation that involves code.
At a high level, I'm with you, of course. But I think that the devil's in the details. Okay, let me ask you a really maybe silly question. In this world, do we still use dashboards?
Yeah, because again, if it solves a problem, then why? Let's keep doing that. Because part of the if you think about this agent stuff, is like, here's the answer to your question, and if you want more information, just click on this thing, and you have a dashboard. And by the way, Tristan is a person who you should go talk to if you have more questions about it. Honestly, I'm very human about this. Like, the whole point is we don't want to automate stuff and eliminate humans. I mean, we just really want to make sure that we're more effective in how we're communicating, and not just so many back and forth and waste of times. Like, if I'm going to go spend time with you, who you know that part of the business, that knowledge, I want to be able to go have that conversation with you, having already done my research, understanding what I know, understanding what I don't know. So when we go have that conversation, we can be very explicit about these things. And that makes us all much more productive and more effective at our work.
It makes me think of let me Google that for you. It could be like a new social thing. Like if you schedule a 30-minute one-on-one session with somebody to talk about a given topic and you haven't had the conversation with the domain-specific AI that they have uploaded a bunch of knowledge to, then like you're wasting my freaking time.
That's actually a great point. I didn't think about it that way, but imagine you can like, I have a meeting with somebody. Like, you should have, part of the precondition of the meeting is that you prepared yourself talking to the AI agent, and you have to set the right expectations. It's not going to know everything, but you're going to be able to extract what it knows, and then you're going to be able to know the stuff that it doesn't know and that you don't know. And then you're like, okay, now we can have a much more productive conversation.
Last week, I was talking to Ben Stansel for an episode, and he was differentiating between observability and analysis, where observability on your business is every week I look at the same 3 dashboards or 18 metrics or whatever, and I'm not actually trying to answer any questions other than, am I surprised by anything that I see? And most of the time the answer is no, actually, I'm not. Fine, moving on with life. And every once in a while I am surprised, and then I have to go down this other pathway. The world that you're describing, I think, is much more focused on the analysis leg of the stool as opposed to the observability leg of the stool. Is that a fair? Like, I want to learn a new fact that I didn't know before.
Oh, that's a good point. No, I think it would subsume all the observability stuff because you're basically can ask questions about the facts that stuff it knows. I can give you the answer, and I can point you to more details. So then that stuff gets kind of streamlined, and then I think it's the unknown stuff that you would be able to empower more. I mean, you even think about it. You're like, I'm surprised about something. And then at this point, it's like, well, let's go use the hallucinations as a feature. It's like, well, give me ideas of why that it could be happening. I'm like, okay, great.
Yeah. What do you think about why questions? Do you think that we're going to get into the land of reasonable answers or hypotheses to answer why questions?
I don't know. The immediate answer. I think what would be a powerful and more immediate thing that you can go get is to generate those hypotheses for you.
Yeah.
I remember one of the first companies I was working with, and they were like, something's happening. Like there's a dip in like some sales. Like we don't know why this is going on. And people go out scrambling. I'm like, but hold on. Let's actually go talk to people. So let's sit in a room, a couple of people you know, and why do you think this is happening? So what is it? We just basically come up with a bunch of hypotheses. And then people said, let's go share these hypotheses in the room. And then what other insight do you have? And people were like, oh, this is great. Like this is just this is a scientific method right here. But just having that, being able to come up with possible answers, right? And then you go figure out, okay, do I have data to figure out how to go do that? Or how would I be able to figure out if that's true or not? I mean, now you're trying to basically set up the experiment. But now let's kind of come up with the list of possible questions of why something may be happening. I think that's going to be a powerful thing. Now we also need to be careful. We don't want to overload and then have a bunch of whys and hypotheses, and then we just end up like drowning that stuff. So I think you gotta always be careful where the pendulum swings and find the balance.
The paper that we were talking about before, was any of that surprising to you? My guess is you probably anticipated that was the result, which is why you did the paper in the first place.
There's 2 points of surprise for me. So the actual result was a surprise. I didn't know to what extent.
And the result was pretty significant. Like the straightforward text to SQL versus text to knowledge graph to SQL is like really different.
It's 3 times more. And then actually when you look at if you put all the questions, all the quadrants together, and if you look at the high schema complexity, I guess it's almost infinity or whatever, because it was 0%, right? So that was super, that was surprising. The first thing that I find incredibly surprising was when I started playing with GPT-4 and saying, holy shit, this stuff knows these semantic web standards that we all started talking about that are like so it knows it. Like I would literally give it a prompt, which I would just paste in an owl ontology and a turtle syntax. I'm saying these words, and probably I bet 99% of people listening have no idea what I'm talking about. These are standards that existed, and it knows that stuff. I said, write the Sparkle query. It would write it down. And I'm like, what the heck is this stuff doing? This is when I'm like, this stuff really knows it, right? That was my first aha moment. I'm like, wow, this stuff might work. And then I'm like, okay, now let's come up with an experiment to go do that. So my first aha moment was before was realizing that GPT-4 does this very well. Then we do the experiments, and then a couple of ahas there was overall the 3 times more accuracy. Again, just with the basic prompting. And that's great because that means that there's so much room for improvement, right? And if we're seeing people now posting, following the benchmark, oh, we're getting 99%, like, okay, great. I knew we were going to improve this. That improvement is not a surprise. It's actually expecting an improvement on that, right? So, and then the other surprise was to know the high schema complexity. And what's interesting there is that threshold was 5 tables. So the moment that you started to go, need to generate joins that had more than 5 or more tables, that's when things would start failing. That's an interesting number. Now, that was on this. Now, is that something I'm generalizing? No, I can't generalize, but it was an interesting number that we know for this experiment. It was after starting at 5. So that's another thing that I'd ask people to go test this out. See, and by the way, people will realize now, I mean, these are the learnings you should take into account. It's like, oh, so if I generate a query that has more than 5 tables, well, it's probably, no, it's not going to be correct. So I can say, I'm not going to answer that question or something like that.
My sense coming out of catching up on the research that you did here, and as well as the less academic stuff that we did internally, is that really the model capabilities are not the bottleneck here. It is more about the productization of, can we get everything that we need into a knowledge graph? Can we expose the agents in the right way and help them traverse the different kind of question types that people ask it and give the right prompts given the appropriate. It feels like a productization challenge, not a like science challenge at this point. Is that your read?
Kind of. So there is product that needs to be done. And I think from the product perspective, it's something much more sophisticated than, let's say, here's a prompt to generate something and I'm done. Right? Because I think that's what people are experimenting right now. Oh, it's like just send something, I get a query back and execute it. No. There's a lot. First of all, there's pre-processing, post-processing to be done. But then actually this falls into an entire agent framework that we're doing. Well, the example I was giving back, right?
Can we talk about that?
Well, I was saying, you got a question comes in. So basically you define a state machine. By the way, this is GoFi, good old fashioned AI. We've been talking about agents and planning for decades and decades. So this is not new stuff. My call out to folks is if you're working on agents and you think you're working on the latest, greatest stuff, please go read some history, right? Don't reinvent the wheel. This is the moment that we need you to advance faster. Don't reinvent the wheel. You're defining a state machine, right? Every state has one very particular thing to go do and has in a decent note to jump to what next state it's going to go do. So you have a question. Is this a fact-based question? Okay, it is. This is a metadata question. It's a data question. You're going to go down this route, right? So you can start building your initial states around that stuff. And then your state itself can be a call to an LLM, or a state can be something more deterministic that you're going to go do. That is the productization that's coming up and things that are being worked on. We're working on this stuff, right? That's one stuff of the product that is needed. The other part you said is like, oh, I need to start one of the challenges of putting this all into the knowledge graph is like, yeah, that's the knowledge work. I need to understand what I'm going to go put in. I need to understand that what I'm putting in here is actually the correct definition of what a customer is. And this is what correct means. Oh, there's multiple definitions of customer. Fine. Then we have to put them all in there. So then what happens to your agent framework? Oh, you're asking a question about customer. It should not just randomly choose. Oh, I'm going to go choose one of these definitions of customer. You should go back to the user and say, oh, I see you're asking a question about customer. We have 5 definitions of customers. Which customer are you interested in? Number 2. Perfect. All right. Now I know that. Let me go back and go do that. That's the type of stuff that needs to happen. I think that's the productization that will occur in managing all that context. That's why I am so bullish on metadata, on semantics knowledge, on data catalogs, right? Because that's going to be the heart of all the AI for your enterprise. You are building that context engine. And so what I tell people is like, why are we doing all this metadata work? Well, right now, before you're doing it, just find data for regulations, for governance, to making sure that my dashboards are working, all that stuff, right? You still need to go do that basic stuff, but you're now getting 2 for 1. Like you do that, and now you are preparing yourself for this AI future, which is already here. So you're putting all that context into that. So and now we want to be able to accelerate that and we want to use AI to help accelerate that too. But that metadata is going to be the core center of the enterprise brain, and that's why I think we're in so amazing times right now. I actually say that before GPT, I would say data integration was an AI complete problem because you can't finding these mappings, all this stuff is just impossible. And I've now stopped saying that because I think it's very clear that we can get 80% of the way there with these LLMs. It's fascinating.
Yeah. I'm with you. Agents are interesting to me because there's been some writing that I've come across recently about design patterns with LLMs, and the idea that in the same way that there are design patterns in software engineering, there could be design patterns in LLMs where it actually takes you many different API requests to get to the eventual output that you're looking for. So this may be an obvious realization for people in the field, but I think many times you take a user that's just experienced ChatGPT before, and they're trying to optimize a zero-shot prompt. Like they want to give it the perfect prompt and they get the perfect answer. But in fact, if you're designing a software system that can be in conversation with an LLM, you can actually get it to do like much, much more interesting things.
This is the point where I think computer science comes back in. So writing code is being commoditized. So coming up with the algorithm to solve the problem, that is still the hard thing. And then you're not going to come up with like here's this description of the problem. write the code for it. It will write code, but that's probably going to be bad code. It's not going to do it. So, but if you break the problem into smaller pieces and you know that this piece is an input, this output here is the input to this thing here, and then you say, here's just really very well defined.
And then you specify tests for each of them. And
then the LLMs will write that code for you. But you did the work of breaking down the understanding. So I think this is where true computer science, yeah, this is my background. I mean, I'm biased. This is my background, but I think computer science is going to come by just algorithms, right? True problem solving, coming up with these systems to go interact and chat and that stuff. It's all about defining these state machines. And what is that? That's defining the algorithms and that you're putting together, and you want to be able to go optimize and stuff. So I think, and then it's like, oh, that particular node, that particular state, it's just a call to an element that does that. And that's going to be some just piece of code that it will probably write it by itself too. So thinking about this, and it's like, oh, this is just one giant thing. I'm going to send it. It's going to do everything, come back to me. We're excited about that right now because it's an easy thing to go do.
That's also not how humans work. I mean, it's not like you have a meeting by starting off by saying 15 minutes worth of words and then expecting the next person is going to say 15 minutes worth of words. Like, we have a conversation.
I love that analogy. 100%. Yes.
That's a shitty meeting.
Those meetings happen. Oh, and I'm sure those meetings happen all the time, right? And 15 minutes were to go in, 50 minutes were to come out. And guess what? They're all disconnected.
Yeah,
what it was about. And
thanks. This has been a lot of fun. I think I'm left with more questions than I came in with, but it's been a fascinating conversation. We used to ask all guests on the podcast, what is one thing you hope will be true of the data industry over the next 10 years? I think that the rate of change has gone up so significantly that actually 5 years feels like forever. What do you think? What's the thing you're most hopeful for over the next 5 years?
Well, what I hope is that people start treating knowledge engineer work as a first-class citizen. It's that data cleanup that I have to go do, that data janitorial work. Like, no. That is critical business knowledge that needs to be managed. And I think there's going to be I really hope, and I'm actually working with folks from the industry and academic point to make the shakeup. We need industry to realize that the reason why we continue to have these problems is because we haven't been investing in managing that knowledge. And so that's one shift that we need to go do and realize how much money we've left on the table, how much money we're losing because we're not doing that. So that's one thing. And then what I want too is from the university academic point of view, having the academic courses in bachelor's, having the bachelor's, master's and boot camps and stuff and saying, oh, how do I become that knowledge engineer or called a knowledge scientist or something? And then people start learning these things because they want to get hired for this. So data scientist was the sexiest job in 2012, right? People are doing data engineering. My hope it's going to be more on the knowledge side. I hope 5 years from now, like that's going to be the role, we're going to have the tools for that. And that's what's going to make our lives much more easier saying, oh, we're having much more progress on solving these data problems because we're investing in our knowledge.
Yeah, I'm with you. I think that it's not just going to be tools. It's going to be pay bands and what are the job responsibilities and how do you justify the ROI of these folks? But yeah, I'm totally with you. Thank you so much for being on. It's looking forward to doing this again soon.
Thank you so much for having me.
The Analytics Engineering Podcast is sponsored by DBT Labs. I'm your host, Tristan Handy. Email us at podcast@dbtlabs.com with comments and guest suggestions. Our producers are Jeff Fox and Dan Poppy. If you enjoyed the show, drop us a review or share with a friend. Thanks for listening.